If f of x equals p of x over q of x, where p and q are polynomials, then this rational expression is called proper if the degree in the numerator is less than the degree in the denominator. It is called improper if the degree in the numerator is greater than or equals the degree in the denominator. If the rational expression is improper, we first must perform long division. If it is proper, and the denominator is a product of distinct linear factors, then we can decompose it with the constant coefficient in the numerator for each of these linear factors. If there's a linear factor that repeated twice, then we would set up two rational terms for the repeated factor, increasing the exponent each time. The exponent tells us how many terms are needed. For example, 2x squared plus 1 over x plus 1 times x minus 2 cubed equals a over x plus 1 plus b over x minus 2 plus c over x minus 2 squared plus d over x minus 2 cubed. There are three factors of x minus 2. We would need three rational terms with x minus 2 in the denominators. Each time we increase the power of x minus 2 by 1. Notice that there are four factors in the denominator. We then need four rational terms when we decompose this rational expression. If the rational expression is proper and there is one irreducible quadratic factor in the denominator, then we would use a linear expression in the numerator for the irreducible quadratic. The degree that we use in the numerator in the partial fraction is 1 less than the degree in the denominator. The degree of the constant a is 0. The degree of the linear factor x minus a is 1. The degree of the irreducible quadratic x squared plus bx plus c is 2. The degree of bx plus c is 1. Note also that if we use the capital letter A already, then we need to use other capital letters than A because there's no guarantee that we would end up with the same coefficient. Similar to the repeated linear factors, if we have repeated quadratic factor that is irreducible, we would have to use as many rational expression for the irreducible factor. In this case, the irreducible quadratic x squared plus bx plus c is being repeated twice. We would then need two rational terms for the denominator x squared plus bx plus c, and we increase the power by 1 each time. The numerator for the irreducible quadratic is still linear, thus bx plus c and dx plus f. For example, to decompose 3x squared plus 5x minus 2 over x plus 1 cubed times the quantity x squared plus x plus 1 squared. We first noted that this is proper because the degree in the numerator is 2 and the degree in the denominator is 3 plus 4, which is 7. The linear factor x plus 1 is repeated 3 times, and the irreducible quadratic x squared plus x plus 1 is repeated 2 times. Remember, the exponent of the factor tells us how many rational terms we need to set up for the corresponding repeated factors. Thus, this is being decomposed as a over x plus 1 plus b over x plus 1, increase the exponent by 1, plus c over x plus 1 cubed, 3 terms for x plus 1, plus we move on to the irreducible quadratic factor. The numerator must be linear, but we used the letters capital A, B, C already. Thus, the linear factor is now dx plus e, plus this irreducible factor is being repeated 2 times. We need one more rational term for x squared plus x plus 1, but we increase the power by 1. The numerator is still a linear expression, which is now fx plus g. We can use any letters that we haven't used before. There's nothing special about these letters.